back at AP Review. This is 2005 Form B, AB FR6. So we're given the diffie dy dx equals negative x y squared over 2. And we're told that y equals f of x is the solution and that f of negative 1 equals 2 is the initial condition. Cool. So first thing we're asked to do is do a slope field at the 12 points that I put here in red. So couple things before we get started. Number one, how much work you show on a slope field is entirely up to you as long as the slopes come out right. So if you feel like you can plug x and y in your head and get the slope correct, awesome, super dope. If you feel like you need to write them out so that you don't screw it up, also a good point because it's not worth losing the probably 2 points for a slope field just because you were too stubborn to write stuff down. The second point to make is that this is a separable differential equation because the x's and y's are multiplied, so I'm going to be asked to solve this, probably in part B or part C, but it's going to happen. So for me personally, I tend to make a little chart when I do my slope fields because I'm not willing to sacrifice getting right answers because I'm too prideful to, or too proud, whichever way you want to say it, to write out stuff. So my slope is negative x y squared all over 2, right? And I'm going to list the points. I always start bottom left and work my way up and then right. I don't know why. I've got no good reason. So negative 1, 0, negative 1, 1, negative 1, 2, 0, 0, 0, 1, 0, 2. Just going to give myself a little room here. 1, 0, 1, 1, 1, 2, and 2, 0, 2, 1, 2, 2. So the very first thing you might notice, and it's up to you if you do, I don't know if you would, is that if either x or y is 0, then the slope is 0. So what I'm going to note right here in green is that all of these that have a 0 in a coordinate, they're going to come out 0 because x times y squared or negative x times y squared is going to come out 0. So this is a slope of 0, right? This guy's a slope of 0. This guy's a slope of 0. This guy's a slope of 0. So there are 4 spots where there's a slope of 0, and I'm just going to put them on first. So negative 1, 0 is a slope of 0. In fact, all of the and this one's a slope of 0. Sorry, there's not 4. There are way more than 4. My brain is slow. So all of these are slopes of 0, right? And all of these are slopes of 0, where either coordinate is a 0 is a slope of 0. So I'm going to do those first. And the reason I'm going to do them first is because they're probably worth 1 point on the AP, right? So I'll inch that over a little. That's probably 1 point on the AP for the 0 slopes. Or sometimes it's 0 or undefined slopes, but the weird slopes are usually worth 1 point on your AP. So I put those on. And then I'm going to do all the other ones, and again, how much you want to do that in your head is totally up to you. So this is going to be a positive 1, right, because the negative times negative. So positive 1 times a 1 squared all over a 2, so that's going to be a 1/2, right? This is going to be a positive 1 times a 2 squared, which will be a 4 over 2, right? So that's going to end up being a 2. Down here, I'll get a negative 1 times the 1 squared, so that's a negative 1/2. I'll get a negative 1 times that 4, so that'll be a negative 2. I'll get a negative 2 times that, so that's a negative 1, right? And I get a negative 2 that's going to cancel, so that's a negative 4, right? Cool. So when I go to put my slopes up, I just need to make sure that they are like somewhat accurate comparatively. They don't have to be exactly right, but they have to be somewhat accurate. So when I put my slopes, it's mostly about how they compare to one another. So this is up 1, right 2. So up 1, right 2, I'm aiming here. Oh, sorry, my bad, I started at the wrong spot. Up 1, right 2, I'm aiming there, right? This one should be up 2, right 1, so 1, 2, right 1, so it should be steeper. That's a slope of 2. Right over here, right, so I did that guy and that guy. Over here at 1, 1, I should have a slope of negative 1/2, right, which means down 1, right 2, so aiming here. Or you could have gone the other way, that's fine. And then this guy is a slope of negative 2, so down 2, right 1, so that's there, right? This guy has a slope of negative 1, so that's down 1, right 1, so like there-ish. So he's steeper than the negative 1/2, but not as steep as the negative 2. And then negative 4 is going to be really steep, 1, 2, 3, 4 over 1, so I'm aiming for like that spot, and he's going to be by far the steepest of my slopes. And that's probably 1 point for the other slope. So a slope field's usually worth 2 points. Cool. Moving on. Part B. Oh, also do a quick double check that they don't ask you to sketch a solution curve in addition, because that's a point that they sometimes throw on for a third point that's a really easy, simple point that we sometimes read past and don't put. They did not ask us to draw like a solutions curve through negative 1, 2 or anything, so we don't have to. Cool. Part B. Write an equation for the line tangent to the graph at f of x equals, at x equals negative 1. Sorry, my brain is tragic. Cool. So let's erase all of our slope field stuff because we don't need it anymore. So that was part A, my slope field. Part B, right, part B asks us for a tangent line at x equals negative 1, right? Well, anytime you're asked for a tangent line or any line at all, you need 2 things. You need a point, and I know the first half of the point is negative 1 comma blank. We'll talk about the second half in a sec. And the other thing I need is a slope, which in this case is going to be my dy dx evaluated at that point, right? So whatever point I get, I'm going to evaluate my dy dx at that negative 1 comma blank, right? So that's my slope, and then I'm going to write my answer in point slope. Well, they gave me that f of negative 1, right? So I was given that f of negative 1 was a 2, so there you go, right? And then I actually already found the value at negative 1 comma 2, right? Because we found that on our slope field. At negative 1 comma 2, or you can find it again if you want. You end up with a 1, and then it's a 4, so it's a 2, right? So I have a slope of 2. So my equation is y minus the y value equals mx minus the x value. And that's great. If they don't ask you to solve for y, which they didn't, you don't have to. If you did want to solve for y, I would suggest that you just add the 2 over and leave him by himself like this, right? You can distribute and clean up if you want, but again, if you make a mistake, it's on you that you took a right answer and turned it into a wrong answer. Part C is the part we could see coming from the beginning, where we are asked to solve the diffie-q, and they tell us specifically here that we are supposed to solve for y equals f of x. The reason that's relevant is because that means that after you're all done, you have to solve for y. So part C, solve the diffie-q. So first thing I'm going to do is I want to move this dx over here with the x's, and I want to move the y squared over. So I'm going to get dy over y squared equals a negative 1/2 x dx. Now you can put the 2 wherever you want, but I'm just going to argue it's easier to keep the 2 with the x's. So when you integrate this side, right, it is not a natural log. I just want to point that out because there's always somebody that accidentally makes it a natural log. So you integrate both sides. When you find this antiderivative, you up the power by 1, which would be negative 1, and divide by the new power. So this is going to be a negative 1 over y. I'm not going to write the plus c. I'm not going to write it because I'm going to keep the plus c over here with the x. So when I up the power, it becomes an x squared, and I divide by that 2, so I get a negative 1/4 x squared plus some arbitrary constant. Now it's up to you when you choose to find the c. You could find c right now if you want. You can find c later. It's entirely up to you. I'm usually the kind of person that waits and finds c later, but it's totally fine if you just decide you're going to plug in and find c now. So one interesting thing to note when you go to find your, when you solve for y, is that you could arguably call this entire thing a fraction essentially over 1, right? Or you could just multiply this. I'm going to multiply a negative y over. Oh, I don't want a negative y. I'm just going to multiply y over. My bad. Okay. Multiply y over. And if I did that, I'd get negative 1 equals this ugly monstrosity plus c times the y. And since I want to solve for y, I'd divide the ugly monstrosity over. So this is not at all a wrong answer, except that I still have to find c. Right? So this is solved for y. And you could leave it like that as long as you find c. Now, how much you want to clean it up is entirely up to you. So I'm going to go ahead and find c. So I solve for y, I have to find c. So when I go to find c, I need to plug in the value negative 1 and 2. So I'm going to get, when I plug this guy in, negative 1 over. When I plug in a negative 1 here, it just becomes a 1 because it's squared. So I get negative 1/4 plus c equals a 2, right? I multiply this entire thing over to the other side. I get negative 1 equals negative 2/4 plus 2c, right? So negative 1 equals negative 1/2 plus 2c. I'm going to add the 1/2 over and get a negative 1/2 because negative 2/2 equals 2c. So I get negative 1/4 as my c. So if I replace this guy with a negative 1/4, I get a totally acceptable answer. Now you'll see different options and that's fine. So let me give you the first of several totally acceptable answers. It would not be wrong to make my answer y equals negative 1 on top of a negative 1/4 x squared minus a 1/4. That's not wrong. Now, some people might factor the negative out. If you factor a negative off the top and the bottom, you'd get a positive 1 over a 1/4 x squared plus 1/4. That's also not wrong. Some people would feel uncomfortable with the stupid 4's in the denominator and might times the entire thing by a 4 over 4 because they don't like it. Then you'd get a 4 on top of an x squared plus 1, which is also not wrong. So any of those answers are fine, right? So just to walk through how this is scored, if you're given a separable differential equation, like this, where the x's and y's can be separated, first point is for separating the variables. If you fail to do that, if you fail to move the x's to one side and the y's to the other, then you're going to get 0 out of however many points. In this case, it was 6. The next 2 points are for finding the antiderivative, so for integrating each side separately, the y side and the x side. Sometimes they only give you 1 point for that. In this problem, they gave you 2. The next point was for using a plus c. The next point was for using the initial condition like we did to find c. You don't have to do that at the beginning. You can do that at the end the way I did. And then the last point is solving for y. So because they said y equals f of x, they need y to be some function of x. But notice that nowhere in there did they say that it has to look like any one of these. The AP had both of these answers, and this answer is a totally acceptable equivalent. So as long as your answer is a right answer, you should be fine.